Hi all. Today in this video we can study about second digital to analog signaling mechanism, that is frequency shift key. In last video you had already studied about the first mechanism for digital to analog signaling, that is amplitude shift keying. So second mechanism is frequency shift keying, and the most common form of frequency shift keying is BFSK. Here two binary values are represented by using two different frequencies. Okay, we have two binary datas, binary 0 and binary 1. For representing binary 0 and binary 1, we are using two different frequencies. And what are the application, or what are the uses of this frequency shift keying? They are used for voice grade lines and for LANs by using coaxial cables. Also we are using for high frequency radio mechanism, and they are less susceptible to error than ASK, amplitude shift key. So frequency shift key for representing the binary data, binary 1 and binary 0, we are using two different frequencies. So this is the figure which shows the binary frequency shift keying mechanism. You can see in the figure we have two data, binary 1 and binary 0. For representing binary 1, we are using A cos 2 pi f1t. Here the frequency is f1. In binary 0, you can represent it by A cos 2 pi f2t. Here we are using f2 as the frequency. So for representing the binary data, we are using two different frequencies, right? And if we are using a full duplex FSK transmission on voice grade line, if we have a graph between signal strength and frequency, we can see a spectrum of signal that is transmitted in a one direction, and also a spectrum of signal transmitted in a opposite direction. So that can be plotted like this. So next variation of a frequency shift keying is multiple FSK. Name itself shows that it is a multiple frequency shift keying. So more than two frequencies are used. Also by using each signaling element, we can represent more than one bit. Okay, so we can represent more than one bit by using a particular signaling element. Also we can use more than two frequencies. That is why they are known as multiple FSK, multiple frequency shift key. And the main advantages of this multiple FSK is they are more bandwidth efficient. Also they are more prone to error. Okay, so frequency shift keying is the second mechanism for digital to analog signaling, or digital to analog encoding. And the third mechanism for digital to analog signaling is phase shift key. Here the phase shift is used for representing the binary data. Okay, and the most common form is binary PSK. Here for representing two binary digits, we are using two different phases. Also we are using differential PSK. That is this phase shifted is relative to the previous transmission rather than some reference signal. So the most common form of phase shift keying is binary PSK and differential PSK. So in binary PSK, what we are doing is we are using two different phases for representing two binary digits. Okay. In differential PSK, we are using phase shift mechanism for representing the binary digits, but this phase shift is relative to previous transmission. So it depends upon the previous history or previous transmission. Okay, phase shift depends upon the previous transmission rather than some reference signal. So for representing binary 1 and binary 0, for binary 1 you can see in figure A cos 2 pi fct, and binary 0 you can see A cos 2 pi fct plus pi. Otherwise it is known as minus A cos 2 pi fct. Here the same frequency is used for representing binary 0 and binary 1, but there is a phase shift of pi. Okay, you can see here this is a phase shift keying mechanism. So phase is shifted by pi. Pi means 180 degree. So for representing binary 1, a cos 2 pi fct is used, and for representing binary 0, minus a cos 2 pi fct. Minus means there is a phase shift of 180 degree or pi. Okay. So this is BPSK, binary phase shift key. Next we have differential phase shift key. So it is an alternative form of two-level PSK. Here the binary 0 is represented by sending a signal burst of the same phase as the previous signal, and binary 1 is represented by sending a signal, it is opposite phase to preceding one. So actually this differential means we are using the phase shift with respect to previous transmission. Okay, for representing binary 0 we are using the same phase as the previous signal, but for representing binary 1 we are using an opposite phase to the preceding one. Okay, that is differential PSK. Next we have a quadrature PSK. That's also a variation of a PSK. PSK means phase shift key. It's more efficient. Also, it's in which each signal element is used to represent more than one bit. Here, the phase shifts are multiples of pi by 2. That is 90 degree, 180 degree, then 270 degree, then 360 degree. Okay. Also here, each signaling element represents 2 bits. Okay. Here, you can see in the figure, quadrature PSK can be represented as, they are used for representing 2 bits, right? So for representing 1, 1, we are using a cos 2 pi fct plus pi by 4. Then for representing 0, 1, it is a cos 2 pi fct plus 3 pi by 4. Then for representing 0, 0, it is a cos 2 pi fct minus 3 pi by 4. Then 1, 0, it is a cos 2 pi fct minus pi by 4. Okay. For representing more than 2 bit, more than 1 bit, we are using the phase shift of 90 degree or the multiples of 90 degree. Okay. That is quadrature PSK. So this is a 4 PSK. So you can have a phase of multiples of 90 degree for representing 2 bit at a time. Okay. Then if you are using QPSK and orthogonal QPSK modulators in a transmission, what we are doing is, this is the figure of modulator which uses QPSK and OQPSK. What is OQPSK? That is orthogonal QPSK, quadrature phase shift key. So by using these modulators, this is the figure which shows the transmission of the signal. So in this, the input, binary input is given to a serial to parallel converter. Then it is divided into 2 parts. That is signal at the rate R by 2 BPS. So the first signal is modulated by using a carrier oscillator. Then it is phase shifted. The second part is not modulating. That is orthogonal QPSK only is happened there. So at last they can be added together. That is the first half and the second half is added together, and the signal will be out. This is actually done in this figure. That is, if we are using QPSK and OQPSK modulators for signal transmission, first we are doing is the binary input stream. It is converted into two separate bit streams. Okay, so by taking alternate bits for the two stream. So one is referred to as in phase and other is referred to as a quadrature phase, and upper stream is modulated by using a carrier frequency or by multiplying the bit stream by the carrier, and this same carrier wave is shifted 90 degree. So you can see in the figure we have a phase shift of 90 degree, but there is no modulation for the lower binary stream, and these two modulated signals are then added together and transmitted. This is the mechanism that is used in this system. If we are using 8 PSK, so you can represent 3 bits at a time by using the phase shift of multiples of 45 degree. Okay. Next, what do you mean by quadrature amplitude modulation or modulator, QAM, which is actually the same figure that is we are used in previous one. That is, if we are using a QPSK mechanism and a OQPSK mechanism in a particular modulator, that they are known as QAM modulator. What we are doing is we are giving an input binary stream and we are dividing that into two parts, and the upper binary stream, which is first which is modulated by using a carrier frequency, then we have a phase shift of pi by 2. Then that output is added together with the lower stream, and the lower stream is not modulated anyway, but added together and then transmitted over a transmission medium. This is the principle behind this QAM modulator. So they are mainly used in analog signaling. Also, it's used in ADSL and cable modem, and it's an extension of QPSK. Actually, here QPSK and orthogonal QPSK mechanism is used, and each carrier is ASK modulated here. Okay, so these are all about quadrature AM, quadrature amplitude modulation. So here the binary 0 is absence of carrier wave, and binary 1 it's a presence of carrier wave. So the upper stream contains the binary 1 and the lower stream contains binary 0. So these are all about digital to analog signaling mechanism. So we have three mechanisms for digital to analog mechanism. One is amplitude shift keying, then frequency shift keying, then phase shift keying. Okay. അപ്പോൾ നമ്മൾ കഴിഞ്ഞ വീഡിയോയിൽ ആംപ്ലിറ്റ്യൂഡ് ഷിഫ്റ്റ് കീയിങ് പഠിച്ചു. ഇവിടെ ഫ്രീക്വൻസി ഷിഫ്റ്റ് കീയിങ്ങും അതുപോലെ ഫേസ് ഷിഫ്റ്റ് കീയിങ്. ഫ്രീക്വൻസി ഷിഫ്റ്റ് കീയിങ് ആണെങ്കിൽ രണ്ട് ഡിഫറെൻറ്റ് ഫ്രീക്വൻസീസ് ഉപയോഗിച്ചിട്ട് നമുക്ക് ബൈനറി ഡാറ്റയെ റെപ്രസെൻറ്റ് ചെയ്യാം. അതാണ് BFSK. അതിൻ്റെ ഒരു വേരിയേഷനാണ് മൾട്ടിപ്പിൾ FSK എന്ന് പറയുന്നത്. മൾട്ടിപ്പിൾ ഫ്രീക്വൻസീസ് യൂസ് ചെയ്യാം, അതുപോലെ മൾട്ടിപ്പിൾ ബിറ്റ്സിനെ നമുക്ക് റെപ്രസെൻറ്റ് ചെയ്യുകയും ചെയ്യാം. ഓക്കെ. തേർഡ് മെക്കാനിസം ഈസ് ഫേസ് ഷിഫ്റ്റ് കീ. ഇവിടെ നമ്മൾ രണ്ട് ബൈനറി ഡാറ്റയെ റെപ്രസെൻറ്റ് ചെയ്യാൻ വേണ്ടിയിട്ട് നമ്മൾ ഫേസ് ഷിഫ്റ്റ് ആണ് യൂസ് ചെയ്യുന്നത്. സെയിം ഫ്രീക്വൻസി യൂസ് ചെയ്യും, ബട്ട് ഫേസ് ഷിഫ്റ്റ് ആണ് അവിടെ റെപ്രസെൻറ്റേഷന് വേണ്ടി യൂസ് ചെയ്യുന്നത്. സോ ദ കോമൺ ഫോം എന്ന് പറയുന്നത് BPSK, അതിനുശേഷം QPSK ഉണ്ട്, OQPSK, ദാറ്റ് ഇസ് ഓർത്തോഗണൽ. ബട്ട് ബൈ യൂസിങ് QPSK ആൻഡ് OQPSK we can use it as a QAM modulator. Also we have a differential QPSK. അപ്പോൾ BPSK എന്ന് പറയുന്നത് ബൈനറി 0ഉം ബൈനറി 1ഉം റെപ്രസെൻറ്റ് ചെയ്യാൻ വേണ്ടിയിട്ട് നമ്മൾ ടു ഡിഫറെൻറ്റ് ഫേസസ് യൂസ് ചെയ്യും. ഡിഫറൻഷ്യൽ ആണെങ്കിൽ നമ്മൾ ബൈനറി 0ഉം ബൈനറി 1ഉം റെപ്രസെൻറ്റ് ചെയ്യാൻ വേണ്ടിയിട്ട് നമ്മൾ പ്രീവിയസ് ബിറ്റിൻ്റെ ഫേസ് ഷിഫ്റ്റ് എത്രയാണോ അത് വെച്ചിട്ടാണ്. സെയിം ഷിഫ്റ്റ് തന്നെയാണ് ബൈനറി 0ന് യൂസ് ചെയ്യുന്നത്. ഡിഫറെൻറ്റ് ഫേസ് ഷിഫ്റ്റാണ് നമ്മൾ ബൈനറി 1 റെപ്രസെൻറ്റ് ചെയ്യാൻ വേണ്ടിയിട്ട് യൂസ് ചെയ്യുന്നത്. ഓക്കെ. പിന്നെ QAM മോഡുലേറ്ററിൻ്റെ പ്രിൻസിപ്പിൾ എന്താണ്? നമുക്കുള്ള ഒറിജിനൽ ബൈനറി സ്ട്രീമിനെ രണ്ടാക്കി ഡിവൈഡ് ചെയ്തു. അപ്പോൾ അപ്പർ പാർട്ട് എന്ന് പറയുന്നത് അതിനെ കാരിയർ വേവ് വെച്ച് മോഡുലേറ്റ് ചെയ്ത് ദെൻ ഒരു ഫേസ് ഷിഫ്റ്റ് നടത്തി ലോവർ പാർട്ടുമായിട്ട് ആഡഡ് ചെയ്തിട്ടാണ് ട്രാൻസ്മിഷൻ നടത്തുന്നത്. സോ പ്രസൻസ് ഓഫ് കാരിയർ വേവ് ഉള്ളത് ബൈനറി 0-1ഉം അല്ലാത്തത് ബൈനറി 0 ആയിട്ടാണ് റെപ്രസെൻറ്റ് ചെയ്യുന്നത്. ഓക്കെ. സോ ദീസ് ആർ ഓൾ അബൌട്ട് digital to analog signaling. that is frequency shift keying and phase shift key. Thank you.